there, guys, coming at you from West Virginia. Doesn't it look like it? Well, all right, anyways, I think it's time for Joke of the Day because it's the best part of the day, and I have my guest here, the lady who created the joke book that everybody loves. This is my daughter, Ellie. Say hi, Ellie.
Hi.
All right, so, are you ready?
I'm ready.
Okay.
Are you ready?
I'm ready. So, Ellie, what do we want?
Low-flying airplane noises.
And when do we want them?
Meow. Okay.
Well done, Ellie. Well done. Such a welcome addition to our class. Okay, so let's take a look now at rational expressions. Rational expressions, first we need a definition, and we need to recall what the word rational means. I've mentioned it many times. Remember, rational does not mean rational dude, like if you're surfing, which we are clearly not doing here. But rational does not mean rational dude mathematically. Rational actually means what? Absolutely. Rational means can be written as a fraction. So in other words, if I have rational expressions, that means I have expressions that have fractions in them. And recall what an expression means. Remember, an expression is not an equation. An equation has a what? Absolutely, has an equal sign. So if it's not an equation, then it is just an expression, meaning that the expression does not have an equal sign. So our definition then of rational expressions is that they are going to be fractions in which the numerator and denominator are polynomials. So basically what happens here is I have fractions and I have complicated fractions. It's not just a simple 2/5 or a -3/4. That numerator is going to have some extra stuff in there, like it's going to have some variables. Same thing with that denominator, extra stuff in there. And it's not going to have just numbers in there. And I just noticed that I misspelled denominator. There we go, I apologize. Anyways, so once we've identified that our rational expression is basically a fraction, we need to recall some very important things about fractions. First off, what can you not have in a fraction? Now recall, it's okay to have negatives in fractions. Recall, technically it's not okay to have a radical in the denominator of a fraction, but a radical can show up. We just fix the form by multiplying numerator and denominator by that radical. But the idea is that having the radical in the denominator is just bad form. That's all. It's not necessarily wrong, just bad form. But what is literally wrong with a fraction? What can you not have in that denominator? Absolutely. You can't have a 0 in the denominator of your fraction. Because if you have, and here I go again, why can I not spell this? Oh my gosh. Denominator. Because if you have a 0 in the denominator of that fraction, we call that fraction what? Absolutely, we call that fraction undefined. And undefined means literally cannot define it. In other words, it can't happen. It doesn't exist. And because it doesn't exist, we cannot define it. So we need to take these rational expressions, these fractions that have complicated numerators and denominators, we have to ensure that we do not put a 0 in that denominator. So what happens is, take a look at these two rational expressions here. I'm going to look at that denominator and I'm going to say, whoa, 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 whoa. That cannot become a 0. And so if that cannot become a 0, in other words, this x plus 2 had better not be a 0, then I'm going to look at this and I'm going to say, well, if I don't want that to happen, that x had better not be a what? In other words, I'm going to consider the domain. Recall that the domain are the numbers that can be plugged into your algebraic expression. Domain typically is your x values because typically you plug into the x. So what I'm going to do is I'm going to take a look at what we call a restriction on the domain. Let me write that down. Restrictions on the domain. In other words, I'm going to figure out what numbers need to be excluded from that domain because these are the numbers that would cause a 0 in the denominator of your fraction. So back to what I was saying, I don't really care what happens in the numerator. I can have a 0 in the numerator of a fraction because if I have a 0 in that numerator, my entire fraction is 0. That's okay. I just simply don't want it to be undefined. So I'm only looking at that denominator and saying, what would cause that denominator to be a 0? I don't want that to happen. So basically, I will look at this and say, well, what would cause it to be a 0? And I'll solve that equation. To solve this equation, I'm going to subtract 2 from both sides, and when I do, I get x equals -2. But when I take that -2 and I put it right here, -2 plus 2 suddenly causes that denominator to be 0, and when that happens, now my rational expression is undefined. So I don't want that x to be a -2. I don't want this to happen. So -2 is the number that needs to be excluded from the domain. Now, let's take a look at another case. So let's take a look at this situation right here. Recall again, I really don't care what happens in that numerator. 0 in the numerator is just fine. It's the denominator that I'm worried about. So this x squared minus 9, I don't want it to be a 0. So I'm going to say, okay, well, what if it was a 0? Then what would cause it to become a 0? And I'm going to solve that equation. Now, with this quadratic, there are 2 ways to solve it. One, I can simply add 9 to the other side, and that would give me x squared equals 9. And then you know that since you want just x and not x squared, you're going to take the square root, that gives me x. But recall that since I took the square root and it wasn't already on the page, that indicates I need to consider the +3 and the -3. What would I multiply together to get a 9? +3 times +3 is 9, but also -3 times -3 will give me a 9. So I need to consider both the positive and the -3, because those are the 2 numbers that I would multiply together to get a 9. And I consider that because the square root was not already on the page. I took the square root of both sides. Now, like I said, that's one way to solve this. Another way to solve it is to say, well, couldn't I just factor that? You're absolutely right, you can factor that. If I'm going to factor it, there's nothing common that I can divide out of every single term. So what I'm going to do is I'm going to set up my double parentheses, and I'm going to split that x squared up as an x and an x. I'm going to split my 9 up as a 3 and a 3. And I'm going to say, since this back sign is a negative, that means I want opposite signs. One's a plus, one's a minus. And then what I'm going to do is I'm going to say, well, if those 2 are set up to be equal to 0, then that means one of those 2 has got to be the 0. So either the x plus 3 is the 0, in which case x is going to be a -3, because I'll subtract 3 from both sides, or that x minus 3 will be a 0, in which case x is a +3. So once again, I get my plus or minus 3. So those are the 2 numbers that need to be excluded from the domain, because if I put either one of these 2 numbers in here and squared them, +3 squared is 9, 9 minus 9 is 0. Uh-oh, I got a 0 in the denominator. Or a -3 in here, -3 times -3 is 9, 9 minus 9 yet again is 0, and I get a 0 in the denominator. Not okay at all. So this is what happens when you have rational expressions. Again, you need to consider that domain, and you need to consider the restriction on the domain and find out what would I put in there that would cause a 0 in the denominator of that fraction. And then x, or whatever variable you've got, cannot be that number. Now, once we've got that idea, let's take a look at all the different things that we can do with our rational expressions. One of them being that we can simplify rational expressions. Because recall, rational expressions are simply fractions. And so therefore, there's lots of things that you can do with fractions. You can add fractions, subtract fractions, multiply fractions, divide fractions. We'll be looking at those in future videos. But before we get there, remember that you can always simplify a fraction, and you should always simplify a fraction if you can. For instance, if you get the fraction 6/9, you should not leave it as 6/9. You should always simplify. Now, let's recall what happens when we simplify our 6/9. Now, you know that what happens is you take your numerator and your denominator and you divide them both by their common number. So in other words, a 3 will go into both of those. 3 goes into 6 2 times, and 3 goes into 9 3 times. So my fraction 6/9 will simplify to 2/3. But I would like to propose to you that what you are doing when you're dividing both of these numerators and denominators by 3 is you are actually canceling out common factors, because factors are things that are multiplied together. So let's step back and think of it this way. What if I took that 6 and I broke it up into its factors? In other words, what would I multiply together to get a 6? Sure, a 6 and a 1, but that doesn't help a whole lot. However, 6 is 2 times 3. What if I broke the 9 up into its two factors, which would be 3 times 3? Yes, I can multiply 9 by, split 9 up as a 9 times 1, but 3 times 3 is a little more useful. So what I'm actually doing when I divide my 6 by 3 and my 9 by 3 is I'm canceling out these common 3's that are right here. And when I cancel out those common 3's, because 3 divided by 3 is 1, I am left with 2/3, which is 6/9 in simplified form. My point of doing all this is to say that when you simplify rational expressions, because remember, rational means fraction, so these are fractions basically, complicated fractions, yes, but fractions. So what I'm going to do is I'm going to cancel out those common factors. But the only way that I can make that happen is if I factor the numerator and the denominator. So the steps for simplifying rational expressions are that you're going to factor the numerator and denominator, factor numerator and denominator, and then you are going to cancel those common factors. And that's all it takes to be able to simplify rational expressions. So the whole issue is you just need to be able to factor. So recall that when you factor, you always look first to see if there's something common that you can divide out. Once you've done that, you head for that double parentheses. So let's take a look at this example. In each of these three, I'm going to simplify them. In the first example, I'm going to factor my numerator. So I'm going to take a look at that 2x and that 6, and I'm going to say what's common to both that I can divide out. Both of them I can divide out of 2. And when I divide this 2x by 2, I'm left with x. When I divide the 6 by 2, I'm left with 3. Now I'm going to do the same thing on that denominator, but notice that with an x squared, 5x, and 6, there is nothing common that I can divide out. So I'm going to go ahead and head for that double parentheses. And when I do that double parentheses, recall that I'm going to cut out half my guesswork right here. I'm going to look at this sign. Because it's a plus, that tells me that these signs are going to be the same. I just need to figure out, are they both pluses or both minuses? This will tell me what they are. They're both going to be pluses. At this point, recall that I take this first term and I split it up into these first two slots. The only way to split up an x squared is as an x and an x. So now I'm going to split that 6 into these back two slots. These two numbers are going to multiply for 6. They're going to add for 5 because these signs are the same. So the two numbers that will multiply for 6 and add for 5 are a 2 and a 3. I'm going to check my outsides and insides just to make sure that I've got this right. Outside I've got a 3x, inside a 2x. Yes, that combines to be a 5x. So I know that I have factored everything correctly. So recall at this point, now that I've factored my numerator and my denominator, what I'm going to do is look for those common factors. I'm going to cancel them out. And recall, factors are things that are multiplied together. On that numerator, I have 2 times parentheses. On that denominator, I've got x plus 2 in the parentheses times x plus 3 in the parentheses. So what I have down here in that denominator is 2 parentheses being multiplied together. So now that I've got those, I've factored, I've got things that are being multiplied on the numerator, things that are being multiplied on the denominator, I can cancel out the common factors. So I've got an x plus 3 on the numerator and x plus 3 on the denominator. They will cancel out, and I am just left with a 2 over x plus 2, which I'll write over here because I'm running out of room. And that is simplified. Now recall, you can only cancel common factors. Matter of fact, that is so important that I'm going to write it up here in all caps. Only cancel factors. Only cancel factors. And recall, factors are things that are multiplied together. And I want to stress that because a lot of people will look at this, they'll cancel out the 6's. Because they'll say, okay, there's a 6 on the numerator, 6 on the denominator, and they'll try to cancel those out. But notice that the 6 is being added here. This 6 as well is being added. Those are not factors because factors are things that are multiplied together. So I cannot cancel these out. And even so, once I've gone through this and I've canceled out the x plus 3's, notice here a lot of people will try to cancel the 2's. But recall, this 2 is being added to the x. That's not a factor. Factors are things that are multiplied together, so the 2's will not cancel. So there it is at 2 over x plus 2. Now, let's take a look at this one. In this case, once again, I'm going to try to simplify my rational expression, which means I want to cancel those common factors. I can only cancel factors. Factors are things that are multiplied together. So therefore, I cannot cancel out these m squareds. That's not going to happen because the m squared is being combined with that negative 3m. The negative 3m is being subtracted from it. Same thing here, this negative 10m is being subtracted. So the m squareds are not factors. I need to factor my numerator, factor my denominator. So when I factor my numerator, I'm going to look to see if there's something common that I can divide out of every single term, and there is not. So I'm headed for this double parentheses. And what I'm going to do yet again is I'm going to say, okay, this back sign here is going to cut out half my guesswork. Because it's a minus, that tells me my signs are different. One's a plus, one's a minus. I'm going to take my first term, I'm going to split it into these front slots, and m are the only two ways that I can split that up. Now I'm going to take my back term, I'm going to split it into the back slots. In other words, I want two numbers that are going to multiply for 10, but since these signs are different, they are going to subtract for a 3. So that would be a 5 and a 2, and I'm going to pop them in here as this, check my outsides and insides to make sure I've got it right. So out here I'll get a negative 2m, in here I'll get a positive 5m, that gives me a positive 3m, I have the right number wrong sign. Recall, when you have right number wrong sign, very easy to fix. Don't switch the numbers, because if you have something other than a 1 here and other than a 1 here as these coefficients on the m's, switching these numbers, the 5 and the 2, will totally mess up everything. So if you've got right number wrong sign, all you have to do is switch those signs out. So that means I'm going to turn this into the minus and this into the plus. So that now out here I have positive 2m, in here I get a negative 5m, that gives me the negative 3m that I wanted. So it is factored correctly. I'm going to do the same thing in this denominator, looking in again to see if there's anything common to each term that I can divide out. There is not. So therefore, I'm headed to this double parentheses. Once again, back sign is going to cut out half my guesswork. Because it's a positive, that tells me signs are the same. I need to figure out, are they both positive, both negative? Look here, they're both negative. So I've got a minus here and a minus here. Split this into the front slot. So I have an m and an m. Now I'm going to split this 25 into the back two slots, two numbers that will multiply for 25. They are going to add for a 10 because those signs are the same. That will be a 5 and a 5. And sure enough, negative 5 times negative 5 is positive 25. Out here I get a negative 5m, and here I get a negative 5m. Yep, that's a negative 10m. So now that everything is factored correctly, I'm going to cancel those common factors. Notice that parentheses times parentheses, there's the two things that are being multiplied on that numerator. Parentheses times parentheses, there's the two things being multiplied on the denominator. So I have four factors, one here, one here, one here, one here. I'm going to cancel those common factors. Notice that the numerator and the denominator both have an m minus 5. So they will cancel out, which means I am left with an m plus 2 over an m minus 5. And yet again, I'm not going to cancel out these m's because they are not factors. Factors are things that are multiplied together. This m is being added to the 2, the 5 is being subtracted from the m, so therefore none of them are factors. And therefore I am stuck, and that is simple as that one will get. Alright, last one. So once again, I'm going to take that numerator and denominator, I'm going to factor each so that I can cancel out those common factors. My numerator, there is nothing common that I can divide out, so I'm headed for the double parentheses. And my back sign, recall, is going to take out half my guesswork. And I'm seeing that my back sign is a minus. That tells me that my signs are going to be opposites. I'm going to split that front term up into the front slots. Y squared only splits up as a y and a y. I'm going to split my back term into the back slots, and there's only one way to split up a 1. It's a 1 and a 1. Notice that when I check outsides and insides, outside I get a negative 1y, inside I get a positive 1y. Those will cancel. That's good. I wanted it to happen because I don't have a middle term. So I know that that's factored correctly. Now my denominator, similar idea, but remember, I always look first to see if there's something common that I can divide out before I do anything else. Sure enough, I can divide a y out of both of these. When I divide a y out of here, I'm left with a negative y. When I divide a y out of here, I'm left with a 1. And now recall, I'm looking for common factors on the numerator and the denominator. And as I look at it, I'm going, wow, you know, this is really close, but this is a positive y and that's a negative y. So that's not going to work. And I can only cancel them out if they are identical. They have to be common factors to cancel. But let's take another look at this denominator down here. Could I divide out more than just this y? Well, yeah, I could take a negative out as well, because when I take this and divide it by a negative y, I get a positive y. When I take this and divide it by a negative y, I get a negative 1. Aha! Now I do have common factors on this numerator and this denominator, and I'm left with a y plus 1 over a negative y. Now, to be completely honest with you, you typically don't see a negative in the denominator of a fraction. It's, again, not necessarily bad to have that, kind of like it's not bad to have a radical, or not wrong, that is. It's not wrong to have a radical in the denominator of a fraction, just bad form. We fix the form. It's not wrong to have a negative in the denominator of a fraction. It's just not very good form. It's not very pretty. So we fix it, and the way that we fix it is we multiply that denominator by a negative 1, and whatever you do on a denominator, you have to do up on a numerator. So I'm going to multiply numerator and denominator by that negative 1, and when I do, on that new, basically it changes all the signs. My denominator becomes a positive y, which looks much better. Positive y times negative 1 is a negative y, and positive 1 times negative 1 is a negative 1. And that's better form. So that's how you simplify your rational expressions. Now let's take a step back and let's consider the domain for all of these. Recall, the domain says I do not want a negative, or not negative, I'm sorry. I do not want a 0 in the denominator of a fraction. So as I look at this fraction right here, I'm only worried about this denominator. Now for that denominator to become a 0, for this x squared plus 5x plus 6 to become a 0, which I don't want to happen, notice if I look at this equation, what I'm going to have to do is factor that equation. Now, when I factor it, it factors this way. So I get that x plus 2 times that x plus 3 equal to 0. That should look seriously familiar because this is solving a quadratic, which we've done. To solve your quadratic, you can either factor it, take the square root of both sides, but only when that's all you got to do, complete the square, or use your quadratic formula. Bam, it's already factored for me. And recall that when it's factored and it's set equal to 0, your zero product principle says if I've got two things multiplied together to get a 0, one of these two has got to be the 0. So either that x plus 2 is 0. Now if that's the case, then my x is going to be a 2. Or the x plus 3 is 0. If that's the case, my x is going to be a negative 3. But recall, if x is a 2 or if x is a negative 3, that's going to cause a 0 in the denominator. So I don't want x to be either one of these. There's the restriction on my domain. X cannot be a 2. It cannot be a negative 3. So remembering that idea, let's take a look at this one. Again, I'm not worried about what happens on the numerator. I'm only worried about that denominator. So I don't want the m squared minus 10m plus 25 to be a 0. I don't want that to happen, which I should have put a not equal, not equal. Don't want it to happen. So here again is a quadratic that I can solve by factoring, completing the square, quadratic formula, but hey, it's already factored right there. So basically, this m minus 5 times the other m minus 5, I don't want that to be a 0. So if this m minus 5 is 0, that m is going to be a 5. I don't want that to happen. M better not be a 5. And that's the case here again. I don't need to worry about how many times it happens, just the fact that it happens. So my restriction on my domain in this one, m had better not be a 5. And then finally the last one, we've considered that domain. We need, again, don't worry about that numerator, just concern yourself with the denominator. So I don't want this negative y squared plus y, I don't want it to be a 0. Here again, to solve that quadratic, let's factor it like we've been doing. Here's its factored form right there. So I don't want this negative y times y minus 1. I don't want that to be a 0. Now, If y minus 1 is a 0, y is 1. That's easy enough. That doesn't confuse too many people. I don't want the y to be a 1. What is confusing is this right here. So in other words, if I don't want that y to be 0, and let me just take a second here to erase just a little bit. It's getting cluttered. You need to be able to see what's happening here. So if I don't want this y to be a 0, like you see right here, consider if y is a 0. Well, basically, to solve this equation, I'm just going to divide by a negative 1. But 0 divided by anything is just a 0. So that means y cannot be a 0. So y cannot be a 1, y cannot be a 0. There's my restriction on my domain. And recall, or I don't recall because I didn't mention it before, but I certainly need to mention it now. When we consider the restriction on the domain, what that means is, in this top case, x cannot be a 2, it cannot be a negative 3, it can be anything else. Any other number you can think of. 0 will be fine. Any other positive number other than the 2 is fine. Any other negative number other than the negative 3 is perfectly fine. Even fractions, even decimals, even radicals, even irrational numbers, anything's going to be okay to plug in here and here. Might come up with a crazy number, but it's okay because it will not cause a 0. These are the only two numbers that will cause zeros in the denominators of those fractions. Those are the only two numbers I'm worried about. Same case here. M can be anything but a 5. Positive, negative, fraction, decimal, irrational number, even a 0. Totally fine. Any of those numbers I plug them in here, gonna work. May get a crazy number, but it'll work. This will cause a 0 in the denominator. That's not okay because when it's 0 in the denominator, my fraction no longer exists and it's undefined. So hopefully this helps with the understanding of rational expressions, what they are, how to consider the domain and restrictions on the domain, as well as how to simplify your fractions. So stay warm. Have a great day.